And we're on the air. All right. So I'm gonna start sharing immediately here. Okay. Now I'm assuming that. I guess I'm going to hide the participants. I just finally realized where that was. Because we had, oh, I hid everything. That wasn't good. What happened? Are you seeing anything?
Yeah, I can see your screen, but it said that you're not presenting to people anymore.
Looks like.
I'm going to have to go back and I wonder what happened. Screen share. Okay, now can you see?
Yeah, I got you.
All right, I'm going to try this hide participants. Oh, I see what I clicked accidentally. Okay. All right. Anyway, because we really didn't have a new lesson last time, I'm assuming we probably don't need to start off with questions, but we could. So I'll open it up. Are there any questions? Any of you that would like to? Any of you? All three of you that you would like to ask?
No, I'm good. Those follow.
All right.
Good.
Get started then. As you can tell, I'm going to make that bigger, so even though it means I'll have to scroll a little bit. So the lesson at 1.6 is entitled Other Types of Equations. Are basically, as you can see, four things we're going to try to cover. Polynomial equations, equations that have radicals in them, equations with absolute value or fractions in them, and then applications. So the objectives down below are practically identical to that. I'm not sure why I duplicated it, but anyway. So I'm going to dig right in, and I'm going to take a problem from the assignment as an example of a polynomial equation. So what do we mean by polynomial equations? Well, we're going to go higher today. Do you see how we have a cube there in number 2? 20x cubed minus 125x equals 0. Well, just because it's cubic doesn't mean we have to right away run away hiding and scared. Can we factor it? Yeah. A fairly easy kind of factoring. We can take out a common monomial factor. A 5 can come out of those two numbers, out of those two terms. So we're sitting here at 5x. Does everybody sees that, right? 5x times the quantity 4x squared minus 25 equals 0. Because it's equal to 0, and we have it factored, we can set each factor equal to 0. Remember the good old zero product property. If you have a multiplication problem that results in a 0, factor or both could be the cause. So we set each factor equal to 0, and we do the algebra to solve. The left side, really easy for 5x equals 0. And the one on the right, well, that's not very hard either. We could add 25 to both sides, divide both sides by 4, and then take both square roots. So you can check these pretty quickly. If you just look up above, if you plug in a 0, this first term will be 0, the second term will be 0, and obviously when you subtract them, you'll get 0. That work. You can go through and check it out. I'm not going to do it right now. But actually, kind of a cool way to check is to use Desmos. So what I'll do is throw Desmos up here. Let's see, what was the equation for number 2?
20x cubed minus 125x.
Thanks. So 20x cubed 25x.
Yeah.
Okay. Now, this thing turns out to be rather large. If I, you can't, it's basically a real scrunched together cubic. So I'm going in, and you can see there are 3 places where this hits 0. 2.5, which is our 5 halves. 0, which we had. Oh yeah, and there's the negative 5 halves. So Desmos, even though you can't see the cubic because it's scrunched horizontally so much, you can see, yep, there's only 3 places where it crosses the x-axis, and it totally agrees with what we just came up with. So, I don't know, Desmos is kind of a cool, quick. You can go through on your calculator and crank it out too. Either way. By the way, how many solutions do we have here?
3.
Does that make sense?
Yeah, I think so. With the highest one being x to the 3rd.
That's right. If it's a 3rd degree equation, remember what we know is that you could have as many as 3 solutions, and we do. Okay, let's go to another one. This is number 6 on the assignment, and you might go, uh-oh, a 4th degree. Now you can see this right here. Okay, a new technique. Well, it's not really a new technique, but we're going to do what's called substitution. I mean, proceed here. So, I know you think I'm crazy, but I'm going to set a letter, u, equal to t squared. When I plug in u for t squared, can you see that I would arrive at this? Right? If u is t squared, then what's t to the 4th? U squared, right? So does everybody see? Now, I know you're probably wondering, what am I doing with u's? Well, what I'm doing is turning it into something we do know how to solve, and then we're not gonna forget this red box here. Come back and substitute back the other way. So I know you can't just willy-nilly change the problem, but you can if you come back at the end. So what is this right here? Well, isn't that a quadratic? And that's what we just spent, I don't know, a couple lessons working on. Now, that looks like an absolute pain to factor, so I'm going to go right to the quadratic. So I'm using the minus b, plus or minus, square root of b squared minus 4ac all over 2a. And I'll save you the pain. After I simplified it, I came up with this number right here. Actually, the square root of 1849 is 43, so here we are down here now. 2 answers, negative 29 plus 43 over the square root of 72, which turns out to be, let me think here, that turns out to be what? 14 over 72, which is 736, so there's one answer. And then negative 29 minus 43 over 72, negative 72 over 72, which is negative 1. So 2 answers are these 2. I mean, this is 2, but that was before I simplified. But that's u. That wasn't what we were supposed to find. We were supposed to solve for t. To do.
Take the square root of each of them?
Well, okay, what I have to do is substitute back again. So for every u, I have to put back in, look at the top right corner. For every u, I have to put a t squared back in, right? And so, right. Brandon, yeah, what you said is going to happen. So u equals negative 1, so t squared equals negative 1. There's my, I'm back substituting. And if t squared equals negative 1, at least if we use complex solutions, we would have what, a plus I and a minus I? And then the other answer was 736. So again, I back substitute t squared. So here are my there's 2 imaginary answers and 2 real ones. And by the way, what do you think happens if you try solving this on Desmos? What happens if you solve this on a graph?
It would cross the...
You won't see the imaginary solutions, okay? So let's, yeah, I don't know if I'm going to do it right now, but if you plug it in, you're only going to get, the graph will only cross, well, I guess I'll show it to you. Okay, so let's go over to Desmos. Here we go, and we'll cover that one up. Oh, we'll leave that covered up, and then this was number 6. Which number was this?
This was 6, yeah.
Looks like I used the wrong one.
Oh.
Anyway, does somebody have the problem written down?
36t to the 4th plus 29.
36x to the 4th, okay.
Plus 29x to the 2nd minus 7.
Plus 29x to the 2nd minus 7.
Yeah.
Okay, again, I'm going to zoom in because we got kind of a narrow parabola here. Well, if you check that, what was it, square root of 7 over
6.
Yeah, you should see that that comes out to 0.441, and you get the negative same. Notice there's only 2 answers, just what I told you. So even though we had 4 solutions, 2 of them were imaginary, only the real ones will show up on. So we have kind of check here. All right. Somebody warming up for a question? Maybe we just...
Yeah, I have one actually. The method that you
Kirsten, glad you joined us, Kirsten.
Oh yeah, hi.
Hi.
Sorry, I was taking a quiz.
No, that's all right. Go ahead, Brandon. What was your question?
The method that you just used as far as 36t to the 4th and 29t to the 2nd, that would only work when you would have like something that can be like the substitution.
Power. Yeah, you're right. That will work with everything.
Right.
Excellent point. Yeah, I forgot. Where were we? Yeah, this is the one we were on. Yeah, you can't. You're right. This isn't going to work well. If this was cubed, because if you said u equals t squared, you can't write. Then you'd have to write 36u to the 3/2, and we don't.
Right.
That's not going to help us. You're right. Only works when it turns out to be a quadratic. That's a good point. Let's do another one. Okay, this is number 18. Number 18, and Brandon, you can see, kind of related to your question, doing a little different kind of substitution this time. You see, this time we have something to the 6th power.
Right.
Guys, we have as many as 6 answers to this. Well, this time, do you see what I did for my substitution? I said, let's have u be x cubed. You see where I'm coming from? Because if u is x cubed, then when I plug it in, I'll get a u. And I'm trying to get to a quadratic because we know how to do those. Okay. So do you guys agree with my substitute here?
Yeah.
And you notice that's just a good old quadratic. Easy. In fact, we can even factor it. Look. Oh, we know how to solve that. Set each factor equal to 0. So up to the blue line, we came down to these u answers here. U equals -2, u equals -1. Of course, that's not what we were supposed to find. We were supposed to find x. So under the blue line, I call that back substitution. So every place we have a u, we're going to plug an x cubed back in. But if u equals -2, we have x cubed equals -2. And over here, instead of u equals -1, we have x cubed equals -1. All right, how do I solve for x? I have to take the cube root of both sides. Answer is the cube root of -2. And the other one we can do in our heads, -1, when you multiply it 3 times, will be -1. Answers, remember, the power, the degree of the polynomial you're solving is the maximum number of solutions, so it's okay to have less. Let's take a look at this one. I think I have this one on Desmos already. Let's take a quick look here. Yeah, that's the one on the top here. Okay, and this one I'm going to have to zoom in on because we want to see where it crosses the x-axis. Interesting, it's not showing it. Oh, there we go. I clicked on it. Do you see one answer is -1? That's what we had. And the other answer is, well, the cube root of -2. And if you check, that is -1.2. So anyway, 2 answers is correct. So here's what that thing looks like. And it does only cross the x-axis. It's only equal to 0 at 2 points. So we have a confirmation.
So would we have to write that first solution as x equals the cube root of the square root of 2i? Like,
no, not the cube root of the square root, just the cube root of, where am I? I'm sorry, I got to find my way back. Here we go. Yeah, the cube root of -2. If I simplified that enough?
right, yeah, that was what I was wondering.
You can't take an I out of that because it's not a square root.
Oh.
So you really can't simplify that one. Now, if there was a perfect cube, like what if it was the cube root of a -16? Well, now we could think of it as 2 times 8, a perfect cube, and then we could have pulled the 2 out. You follow?
Right.
But because 2 is not, I mean, we just can't do anything with that. So that actually is as good as you're going to do. The only downer to Desmos is it'll give you the decimal answer, but still, you can, on your calculator, take the cube root of 2 and you'll see that's the right decimal. Does that answer your question, Brandon?
Yeah, but it brings up another. I thought that a negative square root couldn't really be a possible solution, though.
Yeah, but this is not a square root.
Right. So if it's not a square root, then you can have a negative.
Odd roots of negatives.
Right.
Odd roots are perfectly okay because, for example, right over here, here's one right here. I took a cube root of a -1 here. Did I do it right? Yeah, because -1 times -1 times -1 really equals -1.
Okay, yeah, I see.
So when you take odd roots, you really can. I mean, those are real answers. You really will get negatives.
Okay.
Both real solutions. There are no i's here. Now, if it was a 4th root, we'd have a problem. Anytime you have an even root, Brandon, then you're going to be dealing with complex numbers, and you're going to be dealing with, when you're doing an odd root, just go ahead and proceed. You can take odd roots of negatives. Thank you for asking that because I should have made a comment about that.
Thanks.
Okay, let's look at number 32. It's time to move on to what about equations that have radicals in them? Well, it's just a fancy name for something underneath the square root. So here's our problem right here on the top line. Square root of 5 minus x minus 3 equals 0. The problem is the variable x is under the root. So here's the plan of attack. Get anything that's not under the root on the other side of the equation. So you see that I added 3 to both sides. Once you've arrived at the root being all by itself on one side, square both sides. Because what happens when you square a square root?
Square
goes
root
away,
goes away.
right? And so, look, we just uncovered. Now we can just use good old what? High school freshman algebra 1 to solve, and we actually do come up with a result. By the way, let's quick check it. What's 5 minus a negative 4? 9, right? And what's the principal square root of 9? 3. And what's 3 minus 3? 0. It checks. That was pretty easy, right? So plan of attack. Get the root by itself on one side of the equation, then square both sides, and then just do simple algebra to finish it up. Okay, those aren't too bad. How this can go and be quite a bit harder. Okay, so here we go. So lest I shock you too much, let's take it a step at a time. So this is, I don't know why I said like 44. This is number 44 from the book. What's different about one from the one I just did? I'll just tell you, it's got 2 roots, okay, which is, this is a problem. What would happen if I squared both sides right now?
You would have to take 3 to the 4th.
No. All I'm doing is squaring both sides. And by the way, along with taking 3 to the 4th, we just want to square both sides, right?
Right.
So we'd have a 9. That's not the problem. Can anybody think of it? Well, isn't there a minus sign between those two? So doesn't that make that a binomial? What happens when you square a binomial?
There's middle terms.
Exactly. And guess what the middle terms are going to have in them? Roots. Yeah, so you can't get rid of the roots right away. So here, let's just show you. Okay, well, I did do one thing. You don't have to do this, but I at least put 1 root on the other side. But still, now we have a binomial. Now you have a binomial right here, don't you? So we still have a binomial. It's just that it's not quite as ugly. So when we square both sides, we're going to get a binomial on the right, correct? So here we go. Let's square both sides. The left side is easy. What's 4 squared? I know, it's a game you play with a ball. No. What's 4 squared? Sorry, bad joke. 4 squared is 16. You square root. Root goes away. So the left side's easy, right? Okay, on the right, now I got to take 3 plus the square root of 6x plus 7 times itself. And you get this middle term. Why did I get that? Well, you get 3 times the square root of 6x plus 7 plus another 3 times the square root of 6x plus 7. That's why I wound up with 6 of them. And then the last term, that's easy because that's... But the problem is that doggone middle term. I didn't get rid of the root. Do you see that? So guess what you have to do? Sides again. But before you do that, the idea is get this root now alone. So, well, first I multiplied out the left. And on the right, I simplified 9 plus 7, 16. You know, I just rewrote it a little bit. Now, let's get this 16 plus 6x. Let's subtract that from both sides. 16 from a negative 48, you get negative 64. And if you subtract 6x from 16x, you get 10x. And do you see we're down to this point now? And let's get, if we can we can at least divide, you see how we have all even numbers here? 10, negative 64, 6. We can divide everything through by 2. I'm trying to get it as simple as possible. That's about it. Now we've got root isolated as we can on the right. Let's square both sides again. Yep, I actually mean that. So here we go. Left side squared. So it gets a little bit messy, and you get this. The right side is actually the easy side. 3 squared is 9, and the root squared is this. But the good news is, do you see how we finally don't have any more roots? More like pulling teeth. We couldn't just do a quick square both sides. We had to do it twice. Anyway, finally you can get it to the point where you have a quadratic. I mean, from there you could go ahead and use the quadratic formula, and or whatever, factoring. Well, I don't think I'd want to try factoring yet. But anyway, you could put that in the quadratic and you could go and solve. So do you see the big challenge on a problem like number 44 is more than one root separated by a plus or a minus sign in a binomial? You have no choice but to square both sides 2 times. You know, like here was when we did it the first time, right here. That was number 1. And here is where we did it the second time. That was time number 2. We had eliminated roots, and then we could go to the end. And now it's a quadratic. Okay, now, yes, the numbers are ugly. You know what to do. All right, we're at about almost noon here. Let's keep going. The next type of equation everybody has to deal with, easier, I hope, and that's how do you solve absolute value problems. We'll throw fractions in maybe a little bit later. Right now, just how do you solve what's the answer to this? What's x equal to? Somebody speak up. What's the answer to that?
2.
Okay, is there another answer?
-2.
Is that Kirsten? Must be. You're the only female, and that sounded like a female voice. Way to go, Kirsten. So anyway, you're right. There are 2 answers to this. X equals 2, x equals -2, right? They both have the absolute value of 2. Okay, now, here's how you deal with that. Yeah, like Kirsten said, we have 2 answers from high school math. Here's how you can proceed. So let me just say, what did we do? Okay. To get the first answer, just drop the absolute value signs. And to get the second answer, drop the absolute value signs and change the sign on the non-absolute value side. All right, here we go. Now let's do one that harder. How do we solve this one? Absolute value of x plus 1 equals 9. Do the same thing. On the first part, just drop the absolute value signs and leave it be. And then you still got to solve it for x. But on the other side, drop the absolute value signs and change the sign on the non-absolute value side. Then, just go ahead and do the algebra. On one side, we would get x equals 8. On the other side, when you subtract 1, you get -10. Do those both work? Plug it in. 8 plus 1 is 9. Absolute value of 9 is 9. That's good. How about the second one? -10 plus 1. Yeah, value of -9? 9. Yep, they're both correct. So let me just go over this technique, because when it gets a little messier, you have to think this way. Absolute value problem. Step 1, get the absolute value all by itself. Well, these already were. Break the problem into 2 parts. On the first part, drop the absolute value signs and just go with it. On the second part, drop the absolute value signs and change the sign on the non-absolute value side. And then just do, basic algebra to finish up. Here, let's take a little bit more complex one. I think that's what this is. Yeah. Did somebody have a question? Damon, was that you? Did you have a question? I don't know. Damon, are you there? Well, let's let Damon recover or whatever. But on we go. 70 from the book. Now, here's the problem. The absolute value of x minus 10 equals x squared minus 10x. Well, the absolute value is already all by itself on one side, so we're good that way. So what do? Break it into two parts. What do you do on the first part? You just drop the absolute value sign and go with it. Here. And what do you do on the second part? You drop the absolute value sign and change the sign on the non-absolute value side. So do you see how both these things? Because what happens when you change the sign on x squared minus 10x? It's like multiplying by -1. The x squared becomes negative and the negative 10x becomes positive. Does everybody see that? The rest of this is just basic algebra. I mean, get one side equal to 0. This turns out to be a quadratic. We could factor it, and we came up with two answers, 10 and 1. This one, again, do the quadratic. I was able to factor this one too, and I came up with these two answers. Notice this is a repeat here. So, I mean, I don't have to list this again, this x equals 10. I've already listed it over here. Okay, there is one that doesn't check. One doesn't work. Try it. Left side, what's 1 minus 10? To the top. What's 1 minus 10? -9. What's the absolute value of -9? 9. Okay? On the other side, what's 1 squared? It's 1 plus 10. Why did I say plus 10? Because -10 times -1 is plus 10. I'm sorry. Yeah, plus 10. And 1 plus 10 is 11. Well, it's pretty clear that those two are not equal. You will have that happen where this is why it's very important that you check your work. So we had 3 solutions. We had to reach one of them. So we're down to 2 answers here. You want to take a look, and does everybody get what's going on there?
Sorry, I was having mic issues earlier.
No, it's okay. Yeah, I didn't mean to imply you were...
No, my computer, I have to turn on the mic. Like,
now we all know Damon takes naps when he's at... No, I'm just joking. Totally not true.
I do, though. I'm kidding.
Okay, does anybody have a question here? This is a little bit different to get used to. And, of course, you could check this graphically. How do you check it graphically? Look at that real quickly. Except, let's see, what number was this? 70? Yeah. So I'm going to show you this. And when you have an equals like this, you make 2 separate graphs. You make one for the absolute value of x minus 10, and you make another graph for the other side, and you look at where they cross. It's like in Desmos. Okay, we don't want that one now. So here's the one. Let's see, I got to zoom out a little bit. Here's the one for the absolute value of x minus 10, big V's, okay? And then when you do the other one, that's a parabola, and you can only see it if I zoom out. You see how we have a green parabola and a blue absolute value? Oh, and look at where they cross. Yep, 10 and -1. Right. So there really only are 2 places that those things are equal. So you can check a problem like this when you have equations on both sides, graphing each one and then looking at where they cross. Don't try to do, you can't really put an equal sign in one of these, but you can do them, see how I did them separately, and now I got them both showing up, and then you can check hey, where do they cross? And Desmos automatically puts a second color in for the second one so you can differentiate. It's very nice. Back to our, let's see what else. Yeah, I just wanted to show you this. And this is not a problem on the assignment, but what happens when a problem looks like this? The only difference here is, do you see how the absolute value is not alone? You know what I mean? It's the absolute value x plus 1, and there's a plus 7 there. You've got to get that plus 7 out of there first. So this is, here I've just subtracted 7 from both sides. Now we've got the absolute value alone. Now you can break it into 2 parts. Just ignore the absolute value sign. By the way, isn't that awesome? When did you think your math teacher would ever tell you in any time, just ignore, just ignore a symbol. But you can for part 1. For part 2, value, but you change the sign on the non-absolute. So again, that became a -6 and a +4. I didn't do the algebra here, but what do you do when you've got something else besides the absolute value? You got to get rid of that first. Okay. This is kind of unrelated, but 46 says solve for x, and it's that thing in black. X plus 3 is, how in the world do you get x out from under that crazy power? See what I did? Why would I want to take both sides to the 2/3 power? Well, a rule of exponents is, if you take a power of a power, don't you keep the base and multiply the powers? And what happens when you multiply 3/2 times 2/3? Oh, it's just a 1. And you wind up with just, no power at all. Awesome. Of course, if you do it to the left, you got to do it to the right. You guys remember how to take fractional powers? Bottom means root, and the top means power. So you could first square this. That would be 64, and then take the cube of 64. But it's usually easier if you do the bottom first. Take the cube root of 8, which is 2, and 2 squared is 4. So if you do the bottom first, you will keep your numbers more livable and more, more manageable. I've got one more to look at here. Yeah, where we've got a fraction involved. This is number 20. So once again, I did a substitution. I mean, this thing looks ugly, right? Look at this. You got this ugly fraction. But you notice the fraction is repeated? I mean, basically, even though the power is different, you see how those two terms both have an x over x plus 1 in them? That's an ideal candidate possibly for a substitution. And that's what I did right here. You see how I said, you know what, let's have u stand for that fraction. And then I could write the equation like this. And now it's a quadratic. Quadratics, I hope. That's what we've been working on. And so then you can proceed. In this case, it factors. Set each factor equal to 0 and solve. So are we done right here? No, because the problem wanted you to solve for x. What in the world is this u? So anyway, I have to now back substitute. I had the substitution in the top left corner here. For every u, I got to put an x over x plus 1 back in. And that's what I do right here. Instead of u equals 2/3, x plus 1 equals 2/3. And instead of u equals -3/2, it's x over x plus 1 equals negative. Anyway, because these are both fractions, I can cross multiply. X times 3 equals 2 times the quantity, and then you can, now we actually, have to go back and check, but now we actually have the real solutions, the x values. We'd have been we'd have been in deep doo-doo if we tried solving for x up here on top. Substitution really opened this problem up to be solvable. Okay, I put a lot on your plate. Here, let me show you. Here's a couple people I already told. Here's the assignment. One, by the way, if you looked online before today, you might have seen the odds, and I changed it about an hour before we began. If some of you did more, well, it's probably good for you, but here's the real assignment, and it's now changed online too. So I put a lot on you here. Now, what would you like me to follow up on anything? Well, I'm sorry if I went too fast. What would you like to take a look at? By the way, for those who came in a little bit later, I haven't actually corrected yet. God willing, I'll have it ready, and that'll be the first thing we'll do tomorrow during class. We'll go through that. Okay, so what would you like me to give more screen time to or explain more? I'm just checking to see if anybody texted me, and I don't believe that they have. Okay. So any of you online yet? Questions of any kind, a clarification? I always love those, so.
Yeah, I had one quick thing that I was wondering about. So when you did that last graph, there was the blue V for the absolute value, then the green parabola. I saw that the green parabola by itself ended up crossing the x-axis on 0. So is that why we got like one of the answers? Was that why it was false? Or does that really mean anything at all?
The answer we directed, you don't want to worry about answers that don't work. Okay.
Right.
Why? I mean, you can, if you just look visually, and I put the graph back up, you can see that, hey, there's only 2 crossing points. So one of the, I'll just tell you, one of the problems, when you're getting into more higher degree equations like this, you will get these false answers that come up. It's because we're squaring both sides. Squaring has a way of creating some bogus answers sometimes. That's why you always have to check. In this case, we had what? A quadratic and an absolute value. I don't know what to tell you. There's no way to explain. You can't see the wrong answer up here because it's not an answer.
Right.
The problem was it was created with the algebra that we did. Let me see if I can go back and find that problem. Trying to find my way around here. Where was that one? What number was that?
70, I think.
Yeah. So the problem is, here's what goes on. Because you have an absolute value on the left, that right away makes it into a 2-branch problem. And often one branch will either have a repeat answer like we did here, or one that doesn't check. And the one on the right was a quadratic, which is also 2 answers. So we kind of had dual here. And sometimes an answer will not check on both sides. So the problem is on the left, we ignored the absolute value signs. So guess what? Yeah, we came up with a correct answer, but it's the trouble with ignoring. Sometimes one of the answers, because we ignored that, does not check. I don't know. That's the best I can explain it.
Okay.
So it's this, and by the way, that really is the way to solve those. It's just that, it creates this. Some books call those an apparent solution. I forgot what does our book call it?
Extraneous, I think.
Yeah, extraneous root. Yep. We didn't do anything wrong with the algebra. Because we had to temporarily ignore the absolute value sign, it looked like this worked, and it does, and it didn't. So all the more important, everybody, make sure you take a few seconds and check them. Thanks for the question, Brandon. Others? Question. Coming up on just about 50 minutes here, so it didn't work out too bad. We'd have been in trouble though if I had a bunch of questions from previous. All right, send them my way. It doesn't matter if we stop the if we stop the broadcast, you can still send questions my way. Thank you, everybody. I'll see you tomorrow morning.
Thank you.